like that. But when you're talking about nanoparticles, the actual size of each particles are not, I mean, it's not something that we can see with our naked eyes. So we have to disperse them with some organic medium, whereby we then bring them together to form this polymer nanocomposites. So what we expected at the end of the day is to improve on the mechanical properties of our polymers. So when I say mechanical properties, I mean to improve the stiffness of our material, to improve the strength of our material, the durability of our material. Take for instance now our plastics. Plastics is creating a lot of environmental nuisance. But by adding nanoparticles to our plastic, we make them much more degradable. They degrade faster, they decompose easily and faster. By adding nanoparticles to some plastic, to some polymers that are used in packaging for packaging purposes, we make them to increase the shelf life of our, for instance, our food products. Because if we limit the air oxygen that goes into our food product, then we limit the microbial growth that attacks or that decompose our food. This is actually polymer wood composite. But at the end of the day, by adding nanoparticles to something like this, we will make it more stronger that can compete with our normal bricks that we use, right?
Carbon nanotubes are usually graphene structures which are rolled up in a tubular form.
So what I do is I use nitric acid, I wash them with nitric acid, and I dope them with iron and silver. And then I use that for water purification. As you know, the iron is good for those magnetic properties, and the silver for our antibacterial properties. So we are trying to get both those properties to purify water for different contaminants.
Now, quantum dots are materials that when you expose them to different types of lights, they glow or they fluoresce, as they say. And these can be used in your medical diagnostics, and they've also been used in our flat panel displays where, you know, the industries have moved from your big TVs with the big bumps at the back, and now it's flat screens. So they use these different types of materials to paint them at the back of the screen so that when you shine the light, you can see the different colors. So I have a demonstration here of just how those materials glow. They're just, you know, white powders when you look at them like that. But if you expose them to UV light in a darkened area, then they actually glow.
Different colors.
Yeah, they glow different colors. These quantum dots can be modified to actually be attracted to cancer cells in the body. So when you put them in the body, and then they'll be attracted to the cancer cells. So when you shine a light, you know, different types of light on the body, then they will glow, and then you'll know those specific areas within the body to target when you're doing your radiation or when you're doing surgery and so forth. But we, you know, like I said, as a country, our science hasn't gotten there yet.
This is a small organic solar cell that we've prepared. So this is actually the sample that we will actually put inside our Keithley system to be able to check what the efficiency is of the cell. The application for the organic solar cells is like to have for small applications like for cell phones, for calculators and those kind of things. Say you can also have for warming of clothing, that you can put a flexible substrate. Say this is now my cell phone or my solar cell that I have. If I put it on here, I don't need to have a jacket that I'm wearing.